Okay, so hi everybody, and thanks for joining our tech talk here today. We're going to be talking about a sample application that our solution architect Chris Boley put together, and this is really going to be about kind of UI design, some of the choices he made, and we're going to do a code walkthrough and just talk about how he was able to accomplish the Movies app, which is a great-looking cross-platform application utilizing some platform-specific capabilities around core motion for iOS, but then showing how we can do some of those animations on Android as well. And then There's going to be one in a series of webinars or tech talks that we're going to do utilizing this application to showcase different aspects of what we can do with Appcelerator. So, Chris, I'm going to turn it over to you, and I think to start, maybe just introduce yourself um, and get going there. And by way of introduction, I think I skipped that part for myself as well. My name is Bert Granches, and I'm the Director of Solution Engineering here at Appcelerator. And Chris is on my team, and we're just really excited to get to spend some time and talk about a cool app today. So, Chris, I'll turn it over to you, and then quick introduction and maybe a walkthrough of the app to start.
Right, yeah. So, hi everybody. Good morning, good afternoon. Thanks for joining us. As Bert says, I'm a solutions architect for Appcelerator, and one of the reasons I built the Movies app was before I joined Appcelerator, I worked on a couple of video-on-demand apps where I was working as a native iOS developer and technical architect. And in joining Appcelerator, I think I arrived with a healthy amount of skepticism around Titanium, but I thought, what better way to test out Titanium on not just iOS but cross-platform? Let's see what this thing can do using a subject matter that I've worked with before, and that's where the Movies app got born. So let me turn on my screen, and we can go through a quick demonstration of the app running on iOS and Android. So here we have the Movies app. So on the left, this is an iOS device. This is actually coming from my iPhone. If I tilt my device, you can see that the images move. So this is utilizing the core motion framework that Bert mentioned a moment ago, and we'll come back to that in a bit more detail later on. I can scroll through this list. I get a list of movies collections and genres as well. And I should say that all this data is coming from the Movies database, which I found to be a really good resource. They've got a great API that I could utilize, and they produce these great images as well and link through to movie trailers. So it's based on that I could produce this app. On the right-hand side, this is an Android emulator running exactly the same code base. This again shows the same content. We've got the images cross-fading against each other, and you can see that there's by and large exactly the same experience on iOS and Android, which is exactly the purpose of the application. If I click through here on Android, I'm presented with a list of movies in a particular collection. I can click through to get more details about the movie. I can link through to the IMDb, to the website, and I can play the trailer as well. On iOS, I have a very similar experience. If I click through, I've got the same list. This time I have a slight, very subtle parallax effect. I don't know if you can see that. It works better when you have the device in your hand, but hopefully that comes across on the video as well. But I recommend taking the code and trying it out yourself, and you'll really be able to experience that effect a bit better. Same again, we've got the movie detail screen on iOS. There's a few more effects going on around the extended scroll, and again, I can link through to the movie website and to play the trailer there as well. So that's pretty much an overview of the app.
Great. So, I think it's a great looking app for us, and it really kind of demonstrates some of the power from a UI standpoint. I think when you look at some of the design choices, parallax scrolling on Android, for instance, isn't something that we're taking advantage of. Could you talk about that, and then in terms of how you kind of made some of those choices in terms of what was available?
Yeah, absolutely. So, in terms of design choices, I mean, this is kind of born out of the subject matter as much as anything else. So, movies lend themselves to this, really rich visual experience, and I was able to make use of that with titanium. We can do these great fades and animation effects because we're using native control, so we get great performance. Specifically around this movies list, as you say, we have this parallax effect on iOS, and that is down to the fact that we can get the content offset of the table view that we're looking at here on iOS. However, we can't do that on Android. Now, that is a limitation of the native control that we're using, but I'd love to pass this over to the community and say, if anyone knows of a way of implementing that on Android, then we'd love to know about it, because at the moment that's not something I could replicate on Android that I could on iOS.
Yeah, because you're using the table view. Now, possibly if we use something like a scroll view where we wrote everything ourselves, we could possibly get that effect. But in this case, using the table view as the API was something that wasn't inherently there. So that's interesting. It's interesting. Thanks, Chris.
That's right. And actually, I mean, the app's quite a good example. So on the home screen, this is a scroll view. And the reason it's a scroll view is because I know how much content there will be. I know there's a finite number of collections, so I know that the content will not overrun, and I'm not going to, introduce any memory issues with my app because I've tested it. However, on the movies list, then this could be a much longer list of content, and in that respect, using a table view or perhaps even using a list view is a better option there, because when we don't know how much content we're going to be displaying, it's best to utilize a container which is going to recycle the content within it.
Got it. And you mentioned using the table view versus we also have the list view for those that are listening. Any reasons for choosing table view in this case over list view, or what are some of the advantages to list view over table view?
So yeah, certainly if for high performance, then list view is the way to go. If you have a large amount of data that you need to present, then we would always recommend using the list view. However, the list view does have some constraints in terms of access to the views that you're presenting. So you don't get direct access. You have to access it through a template. So for example, on iOS, I wouldn't be able to do this scroll effect with parallax using a list view because I couldn't interact with the images directly. So that was kind of one of the reasons. And to be honest, it's also down to my prior experience. So I've worked with table views. I understand the API. When I was writing this app, obviously I have a much better understanding of list view now. But again, it's like if you try out a container, if you find the performance is fine, then there's no reason not to go with it. You don't have to optimize too early and find that you're constrained in other ways, and it might restrict you from doing a particular UI that you wanted to do further down the line.
I like that, actually. Optimize too early. I think a lot of times we take that into consideration right away and maybe get ourselves into a problematic area when it's not even necessary. That's a good point. So cool. Why don't we go ahead and check out some of the code and walk through some of the examples. And as we kind of get into that, it'd be interesting to know from the experience of building out the application, how much of the code is actually reused across platform versus platform-specific aspects. Can you talk a little bit about that?
Yeah, absolutely. So I'd say, I haven't done any kind of real understanding of the exact metrics of cross-platform usage in terms of code, but I would say it's well over 95%. We've talked about some of the platform specific features, which obviously you understand that you have to write code specifically for individual platforms, but just to keep the look and feel and the UI consistent between iOS and Android, we're talking of 95+% code reuse. So there's very little branching of code in this app, and actually the branching of code that there is all done at compile time. So it doesn't impact performance based on switching as the application's executed, which is really good. So in terms of code, so I've opened up Studio here. If I start with the alloy.js controller file, so this is basically the starting point of our application, and it's where we like to set up anything that we need to configure before the first view of the application is displayed. So, for example, I'm doing a number of things here. I'm setting up some events, some properties. I'm setting up some of the device configuration for the particular device that I'm running, and I'm caching that. So, for example, I don't have to go down to the native platform to ask for the DPI, for example. I'm storing that in JavaScript so I can utilize that later, which again aids performance. I'll gloss over a few things here which aren't actually being used in the Movies app, and I'm just going to go down to this layout block here. So one of the things that I decided to do when I was building the application was kind of lay out or configure the layout for the app ahead of time. So I do this on launch. It's not a huge amount of code to run through here. Obviously, we could, if there were a really large number of views that we were calculating elements for, then perhaps you want to split this up and only execute this when that view is displayed. But there's not a huge number of screens that I'm presenting, so I'm doing all of this when the application launches. But the reason I wanted to highlight this was because the way this is laid out and the way I've written this is that I can test this function. So, for example, I can call this calculate element dimensions with a different size, and I can look at the result of this, and I can write unit tests against it. So it's quite a nice feature, right? So I can maybe test this against a device which I don't have yet. For example, if Google announces a new Nexus device tomorrow, I know the screen dimensions, I know what my element dimensions need to be. I can run this and I can write some unit tests around that. So I know that when that device becomes available, even if I still don't have it, I know for certain that that my app's going to look correct. So I think that's quite an important thing, that sometimes factoring your code in maybe not the most simple way, but a way that's going to be helpful for unit testing, can be really important.
No, that's a really good point. And we're not going to talk about unit testing in the application per se today, but in the example that you provided, the unit tests are available for people to go check out. So definitely, if you're looking for a good example of that, you can check out the code base that we published earlier.
Right. Yeah.
It's a great point. So I know that the navigation aspect, there's quite a few questions on the navigation controller for this app, and using platform-specific navigation patterns over a cross-platform one. So I just want to kind of get your take on how you implemented a cross-platform navigation scheme where you're using the platform-specific control.
Yeah, so again, this is a pattern that we use across a number of our kind of sample and demonstrator apps internally, and I think it's something that we like to promote, is that we separate concerns of the application. So here we have a file which all it's doing is handling the navigation structure, and I'm exporting a module here which has a number of cross-platform generic methods. So here's one called push, there's one called pop, and basically I'm passing in the controller and some arguments, and then this module will carry out the necessary layout, whether it's iOS or Android. So if it's iOS, then it's going to be using the UI navigation controller. If it's on Android, then each time we push a controller, we're actually creating a new window. again, that's entirely up to the individual developer and the individual use case. You may want to have just a view stack and just swap out views, but it's a really good idea to separate that out into a separate controller or a separate library. Then it means that your controllers can just call methods here and not have to make those platform-specific decisions in the individual controllers themselves. You just you encapsulate that away into one place, which I think is another really good piece of advice.
Okay, no, that makes a lot of sense. Makes a lot of sense. And then in terms of the impact of cross-platform, one thing to note, and just kind of curious on your thoughts here, but if you were to have done a completely customized UI, then that would have been code that would have been 100% reusable cross-platform. But trying to align to those native experiences it's all about a design choice, right? You can go either way.
Yeah, absolutely. Yeah, we have lots of different takes on navigation within the applications that we write, and obviously, our customers' applications are, they vary wildly in how they've been designed. The individual platform vendors have their own, if you like, their own kind of navigation structures, and I would suggest that it's a really good idea to utilize those if you don't want to alienate your users. And certainly we would never recommend imposing an Android navigation structure on iOS and vice versa. I think that would be a very easy way to really kind of alienate your users and give something that they wouldn't be expecting. So, but like you say, we have apps where we have completely cross-platform navigation, and as I mentioned before, there's an app that I've worked on where it's just a case of swapping out kind of content views within one main container. And there's no reason why that doesn't work. It very much depends on use case.
Perfect. Cool. So let's go ahead and look into some of the more cross-platform areas around how you structure the table view layouts and such.
Sure. Yeah. So if I go into the home screen first. In terms of cross-platform, this view, we're talking this home screen here. So as I said before, this is a scroll view on both platforms. So it's a case of coming up with a fairly custom layout routine, which is just going to go through and lay out the cells in order as they come back from the server, or in this case, as they come back from the local data that we're using in the app. In the movies list view, if I click through there, then we're in this controller here. As we said, it's a table view. To be honest, there's not a huge amount to talk about. It's most of the logic here is around loading the data. There's some stuff around analytics in here, handling the search. So this view will handle search results as well as just displaying a list. And again, when we come to populate the movies, we're just iterating through a list and adding those items to the table view. And just kind of briefly looking through this, there's not a huge amount of platform-specific code. So for example, there's one line here for iOS where I know we're going to go into this in a little bit more detail later on, but this is just around hiding the nav bar at the top, which we don't have on Android. So other than that, there's very little platform-specific code.
And Chris, just a quick question. So I know you've got a really deep background in native iOS. Comparatively in terms of the amount of code that you're writing for an Accelerator versus say Objective-C to kind of achieve the same effect, would you say that you're getting a lot of benefit in terms of writing less code, or is it about the same?
To be honest, I would say there is quite a lot of benefit in terms of the Titanium APIs, certainly around table view. So, if anyone's spent any time with the iOS UI table view, you know that you're talking of like a delegate and data source pattern where you have to create the table view and then you have delegate callbacks for implementing the content for each row, and setting up the heights and handling the click events and things like that. Here we're talking of very little code, and in terms of the view, we create a table view. There is some iOS specific code. Again, this is actually only due to the way I've implemented the navigation bar at the top. The code, or rather the properties for the styling of the table view, again, it's pretty straightforward. We're just saying we want it to fill the view. So, and actually populating it, again, we only have this one routine here, this one loop where we're going through the data and populating the cells, and I would strongly suggest that there's a lot less code here than there would just be on iOS, let alone the fact that we get Android as well, kind of for free.
No, that's a great point. That's a great point. So thanks. And I know that we can talk about it a little bit later, but since we're here, it might make a little bit of sense. I know that when we're you're doing a little bit of optimization around the cross-fading and of the table, to where you're only you're instead of doing a bunch of animations on all of the cells, you're really focusing on what cells are actually in the view. Could you just talk a little bit about that choice and how that can impact the performance of your app?
Absolutely. So on the home screen, this fade between the images and the cells. If I come down to the code here, so these are the methods involved, and actually this animate cell images method is what gets called for each individual cell. And we're making a decision here to say if the cell is visible. I won't go exactly into the maths, but it's fairly straightforward. We're just saying that if any part of this cell is on screen, then we're going to animate it. If not, then we'll ignore it. And animating all the cells on iOS was absolutely fine. On an iPhone 6, for example, it had absolutely no problem doing animations across I think there's 24 cells, which aren't all visible at the same time. However, when I wanted to do that on Android, I have a Nexus 5 device that I was testing on. It was struggling. We know that animation on Android can be a bit of an issue. Certainly, especially fades between images. That's quite a computationally expensive operation. So doing this optimization meant that the Nexus 5 performed really well. So again, I guess it goes back to that point about optimization. It's deciding when to do it and knowing what kind of options you have. And then this is kind of like implementing a table view manually in a way, because we're saying, right, we know we have these other items, we're not displaying them, so we're just going to ignore them for the time being. And again, it comes down to the individual use case, but doing a bit of optimization means that we can support more devices than maybe we could have done by just animating everything.
No, that's really cool. And what I think is important about this is, one, it's you started to optimize after you noticed the problem when you're building the application. So you achieved the desired effect, and now it's about how you can come back and improve upon it. And then secondly, I mean, you're talking about 13 lines of code here to dramatically improve the performance of your application. So it's not a lot of overhead to get to that. And very, one line of platform-specific code to handle a little bit differently how Android looks at the content offset versus iOS in the table or in the scroll view. So, great to be able to see, the parity between the platforms in terms of the UI and UX as well as the performance increase. So thanks for diving into that. So let's talk a little bit about the core motion stuff. So this is going to be iOS platform specific.
Right. Yeah. Absolutely. So this is one of the platform specific APIs that Appcelerator introduced support for. As soon as core motion was available, basically. It's and I thought, hey, I've got this. It's quite a nice little use case where I can, let's try it. I didn't know whether it was going to look very good. Sometimes these kind of effects can be actually a little bit disorientating and maybe a bit over the top. But in this case, subtle events, subtle effects like this, can introduce a little bit more, I don't know, dynamicness or whatever you want to call it into the app, which is quite nice, and especially when this is the subject matter, it works. So we wouldn't necessarily recommend using this kind of thing for just any old app, just for the sake of it. But so again, to use Core Motion, we're using a compile time flag. So again, all of this code is completely removed from the Android code base when it gets compiled, which is really nice. So we don't have to worry about any kind of runtime switching that's going on. And what we're doing here is we have a property, so we're checking that the user has decided to actually enable this or disable it, so you can turn it off in the settings. And again for optimization, when the window gets blurred, so when the user navigates away, then we're saying, right, there's no point listening for this anymore because we're on a different view, we can't see anything. So again, that may impact the performance of other views which are in front of the user. So it's a good thing to optimize there. When we register, it's a very simple API, and actually there's a lot of code here which is just kind of additional code to make sure we don't register twice and things like that. But actually we're only talking of half a dozen lines of code to implement this. And actually once we've gone through the checking to see if the device supports Core Motion, whether it's active or not, we're saying we want to update the UI every 50 milliseconds, and again, that's a number that we could tweak depending on either the effects that we're looking for or the devices that we want to support. And then when we start the device motion updates, we get this callback method, and if that callback is successful, then all I'm doing is changing the image top and left property based on the pitch and roll of that Core Motion event. I've left in some debugging information, which, again, if you check out the code, please do uncomment this and just play around with the device and see what numbers you get back. And using these numbers in a different way, I came up with this multiplier of 15, again, which is just trial and error to see what effect I wanted to create. So it's very much trying out the effect and seeing how it works for your app and on your devices.
That's great. And then, so in terms of adding Core Motion to a project, can you just quickly go over what it takes to add Core Motion to a project? Because by default, it's an external module, right?
You know what? I can't even remember if it is. I don't think it is actually an external module. So, oh yes, it is. Okay, so it is part of the core Titanium framework, but you have to explicitly add it to say you want to use it. But it's part of the standard SDK. And then if I want to utilize this, all I'm doing is, again, I have a compile time switch to require the Core Motion module at the top of my controller. And that's it.
Well, that looks pretty simple. So thanks, Chris. So I know that you've incorporated a lot of little tidbits and tricks into here in the application to kind of achieve some of the desired results. We talked about some of the crossfade cell animations and the performance that you did there. But one of the other cool things that I noticed that you did, and I know that some of the community was asking about as well, was really around how you achieved on iOS that transparent navigation bar. So
right.
Would you be able to kind of talk about how you were able to achieve that transparency on the navigation bar?
Yeah, absolutely. So the kind of the simple answer to that is that it's a fake navigation bar in that we're utilizing the UI navigation controller to handle the navigation stack, but we're not using the navigation bar itself. So instead of that, I know that this navigation kind of bar look here, I know how big that is. I know that's 64 pixels, including the status bar. So what I can do is move my table view down by 64 pixels and create this header view here. And then I can utilize the scroll event to adjust this navigation view, this navbar view that I have here. So I can adjust the opacity of that as I scroll up and down. So I'll go into that into a bit more detail. So as I mentioned before, we have this table view, and for iOS only, as you can see, I'm only including these views for iOS. I have a table view header, and I have a pull view. And the reason I have both is that the header will provide me this view as it is now, but I also want to be able to pull down here and show this red background, and that's what the pull view is there to do. The purpose of the pull view really is there to do a pull to refresh interaction, but we don't need that for this particular app. If I go into the styling, I can see that the header is 64 pixels and has this red color. And the pull background color of the table view is the same color. So that's how I achieve that effect there. If I look inside the controller code, I'll come down to the bottom here to the iOS specific code. So this is the block of code which is handling the parallax effect. But at the top, I am listening to the scroll event of the table view, and then I am setting basically the opacity to the background view of the navbar, and I'm basing that on the offset divided by 44. So once I get 44 pixels down, then the navbar has disappeared, and that's basically how it works. To be honest, there's a lot of this kind of thing happens when you're writing applications, and maybe it's kind of something that I've picked up when I've been writing native iOS apps, is that you might see a control or a particular interaction, and you're like, that's not the standard element I'm used to using. Well, there's nothing to stop you from building that element out of views manually. Obviously, we'd always recommend using the standard controller for performance, but if it doesn't give you a particular functionality that you're after, then you can build it from first principles, as I'm doing here, and then it gives you the ability to kind of play with it in a different way.
Yeah, that's really cool. Thanks for talking about that. I know I'm going to be using that in one of the next apps that I write as well. And you bring up a good point, is that you can certainly create any type of custom UI that you want on Appcelerator and Titanium, which is key value add for what we try to do with the platform. But and one thing that we haven't talked about here, and we're not, we try to keep the code fairly simple and straightforward. But the ability to, say, create a reusable component like a widget within the Alloy framework, and then that makes it reusable, very portable from application to application. So maybe we'll look at that in an upcoming Tech Talk. So thanks for getting into the details on that. So I know that we have some questions that have been asked. You can certainly get to that. But anything else that you want to talk about regarding the app at this point in time?
I guess the only thing I would say is that I mentioned at the top about my kind of slight skepticism around using JavaScript to create native apps, and one of the reasons I built this app was for my own kind of my own understanding of Titanium, which is obviously this has really helped, but also that I wanted to test out those theories that hey, I can't possibly write a high performance beautiful looking app using JavaScript and it work across platform. And I'd like to think, obviously that might not answer, this app doesn't answer that in every use case, but hopefully this goes a long way to showing that, yeah, you definitely can, and I was proving that to myself as much as to anything else.
No, that's awesome. It kind of makes me think how you got hired here, but I'm glad you did. Yeah. No, I appreciate it, Chris, and great job on the app. It looks fantastic, and seeing it run on iOS and Android is great. And I know that you even got some of it working with mobile web from the same code base, but we'll call that experimental right now, and maybe look at that upcoming episode.
Yeah, maybe a later episode. Yeah.
Got it. So let's take a look at some of the questions that we have here and go through and just see what we can get answered. The first one was around the code, and yeah, it's for anybody who is curious about getting access to the code. We have made it open source. It's on GitHub. The link's been posted, but it's github.com/accelerator/movies, and you can get access to the code. Now, one thing to note, we mentioned this is going to be a series of webinars on utilizing this application. The current code base has just kind of a local data set as JSON flat files. In an upcoming release or an upcoming tech talk, we're going to be talking about how we can use the Accelerator MBAS to connect to these types of data sources and streamline that process. So keep in mind that we'll be publishing an updated branch to the Movies app that'll have that code in it at that time. But yeah, you can certainly go, and we recommend getting access to the code, and we'd love to hear your thoughts about it. So don't hesitate to tweet about it as much as you like, and leave us any issues or comments in the GitHub repo. Now the next question, this is actually pretty interesting, I think for this application it's probably a little bit different than how we would look at structuring some other applications. But the question is, the Alloy.js in the project is a bit heavy on globals for an app of this size. As projects start to get bigger, what are the best practices to keep Alloy.js from getting unmanageable? And I know I have some thoughts on this, but Chris, do you want to kind of talk to that?
Absolutely. So, to be honest, I didn't write it in that way, and I would certainly recommend, try and keep the Alloy Globals namespace as free from properties and values as you can. The reason we've done it for this particular app was just to try and keep the code base as simplistic as possible. I would normally abstract a lot of this stuff away and encapsulate it in another in another module. But yeah, and as the question says, certainly as the app gets more complex, we would definitely recommend not putting everything in Alloy.js as I have done here. So this was really just to try and simplify the code base a little bit.
Right, and Alloy's, the Alloy.js is really for about initialization of the application and how you can leverage that and establish some app-wide events. A lot of times we'll leverage another singleton. We actually have some internal apps that leverage a singleton that we call core, which allows you to do a lot of app-specific behavior and reference things like the navigation controller from a global entity and things of that nature. That's actually a repo we can post up here as an edit on this question, and by one of our other architects, Rick Blaylock, who kind of manages the core repo, and you can see that at his GitHub. It's open source as well. So we'll post that just here and after the call to the question thread. But it's a good question, and hopefully that answers it. Now, the next question is, the community is starting to get behind the Titaniumifier. What is the Appcelerator recommended way of reusing NPM modules like async, superagent, etc.? Yeah, so that's actually, it's a good question. I've played around with Titaniumifier. Have you had a chance to look at that, Chris?
Only very briefly.
Yeah. So at this point in time, I don't think there's a recommended way of reusing those modules. The Titaniumifier certainly seems like a great start to going down that path. You can always take advantage of pure JavaScript libraries directly within any Accelerator application. And if you're using web views and things of that nature, you can leverage web-specific libraries as well, like a jQuery within the web view. But we'll have to kind of keep our eyes out on Titaniumifier and see how that goes. It's certainly an exciting product and or project, and we'll be looking more at that as it advances. So thanks for asking the question. And then, so the last question, how's the parallax done on scrolling in the movies list? And I think we talked about that a little bit, but you may want to talk just a little bit more, Chris, on, you were doing some referencing of kind of where the scroll is and things like that. So if you could just quickly go over that one more time.
Yeah, absolutely. So, yeah, you're right. I don't think we covered that in detail. As I said, at the bottom of the movies list controller, we have this iOS-specific block of code. And what we're doing is we have this function which sets up the listener events. So this is actually in place for when the application is talking to a remote data source. And actually using the current code base, this listening to the post layout event of the table view is not necessary. But I'm doing that here so that I can get the absolute height of this table view. So I'm not reliant on looking at the device. I want to see what this table view is, and if I might change the top offset, or I might change some of the metrics of it down the line, and I know that I'm always going to get the absolute height of this table view. I need that so that I can work out the offset for each cell. So basically, I know that I've decided that each of these images is 16 by 9. I know that I get a 16 by 9 image back from the server, and I know that they need to be at the top of the image, at the top here. And then when the cell is at the bottom, you should see the bottom of the image here. So as I scroll wildcard, you see that the top of the image is displayed when I get up to just under the scroll bar here. The status bar, and then I get to the bottom of the image when I'm down here. So I need to know the kind of offset per pixel that's going to require as I move up and down the table view. So I set up those constants. Once I've got this post layout event and I know how high the table is, then when we have the scroll event, we take the offset and we call this update table view. And again, in a similar way to doing the core motion effect that we have on the home screen, we're going across the different rows in the table and updating the offset of the image within that table, given the offset and the index of that row. In this final method that I'm calling, it's actually quite simple. There's that you can follow the maths hopefully yourself, but all I'm doing is checking that I'm not going beyond the bounds. So if I get an erroneous scroll event, for example, then I want to make sure that I only top out at 0 at the top, and I only bottom out at the correct negative value. So I'm showing the bottom of this image, and the image starts up here somewhere. If hopefully that makes sense. But yeah, it's kind of like a two-stage process. It's about setting up these constants and then using those based on the offset of the table as you scroll.
And so that's just triggering off the scroll event of the table itself, right?
Yeah, that's right.
And where are you setting that up?
Sorry?
Where are you setting up that scroll event?
It's just here.
Okay.
So yeah, pretty straightforward. I mean, I had looked at other ways of doing it. So the reason I actually decided to implement this was that it was effect that you see in the WhatsApp app. If you have a bunch of images in a message thread, if you scroll up and down, you'll notice that they have this pretty cool parallax effect. And I was like, I can do that. And actually, it's a good example where you might think Titanium, it's not going to receive those scroll events fast enough to make this work, but actually it's perfectly fine. It's just a case of setting up the constraints so that you know that you can't scroll above and beyond, or you can't set the image to be above and beyond where its maximum value should be.
Very cool. Very cool. Thanks for that detail. And then the last question that we have today is just around leveraging require, loading in large files versus several smaller files. And not to get too deep into that one, I think, I don't know about your your experience with that, Chris, but I know with mine, I try to break up my libraries into as small a library as possible, mainly because it just makes it so much easier to manage. You can have some fairly large libs that you require into your applications, and that can be fine. There's a note about Android having some differences in terms of some of the files it can access. But in general, I would say trying to keep your focusing not necessarily on the size of the lib, but really the manageable aspect of that library, and breaking it up as necessary to make it easier to use would be my recommended approach. Anything to add on that, Chris?
No, I absolutely the same. I guess one thing I would say is that I have, some of the apps that I've worked with customers on. You see people, requiring in either in Alloy.js, or once you kind of step through the code, you realize that actually, these require statements have been executed when the app is launching, and any time that you can avoid that is a really good idea. So, and as the question says, on Android, the JavaScript evaluation can be a little bit slower, so certainly at startup is a really important time when you want to try and avoid that.
Yeah, that's a great point. Great point. Okay, well, I think that's going to cover it for today. I really appreciate everybody joining in. There's a poll that we put together that just giving your feedback on the application, or the feedback on the webinar itself today. We'd love to hear from you. But we really appreciate you joining. And when we talk about what's next, like as I mentioned earlier, the next version of this, or the next session of this webinar, is really going to be about how do we tie this into that back-end data center, or data source. So Chris mentioned that we're using the Movie Database, which has a great API, but having to rely on a data source for a mobile application, and a data source that could potentially change, raises some problems. And how can we abstract that so you're not having to get around the application? And I think that you'll see with some of the new things that are coming out from the platform in the near future, we make it really, really easy to connect those data sources. So we'll be looking to have another one of these tech talks in just a couple of weeks, where we can showcase a lot of what we're doing, and at the MBAS level, mobile backend as a service piece, to help make it a lot easier to connect to those types of data sources. So, Chris, thanks again for your time, and
thanks so much, Bart, and thanks for everybody for joining.
Yeah, appreciate everybody joining. Have a great day.